Ever wonder how your smart home devices all talk to each other? Or maybe how first responders can possibly communicate in a disaster zone where there's no cell service? Well, the answer is often this incredibly powerful technology that's, believe it or not, hiding in plain sight. It's working quietly in our homes, our cities, and even in the most remote corners of the planet. So today, we're going to pull back the curtain on this hidden web, mesh networks.
Okay, so what in the world is the connection between your sometimes spotty home Wi-Fi, a team of firefighters battling a blaze out in the middle of nowhere, and a futuristic smart city? I know, it sounds like a riddle, right? But they all share this common and incredibly resilient solution to a really fundamental problem: how to stay connected when a single central point of failure just isn't an option.
All right, to really get what makes this tech so special, you kind of have to unlearn what most of us know about our home Wi-Fi. We need to start thinking beyond that one all-powerful router that sits in the corner, and instead step into the mesh itself.
So, on the left, that's the kind of network most of us have at home. It's called a star network. See how everything has to connect to that one central router? If that hub goes down, poof, the whole network goes dark. It's game over. But on the right, you've got the mesh. It's this beautiful web of connections where every single device, or node, can talk directly to its neighbors. There's no single point of failure.
You know, at its heart, a mesh network is basically a team effort. Each device connects directly and dynamically to as many of its neighbors as it can. They all cooperate to pass information along. It's like a bucket brigade for data. It's a totally decentralized, collaborative system.
And this brilliant design leads to two properties that are honestly almost magical. The first is self-healing. If one of those nodes fails or a connection gets blocked, maybe someone turns on a microwave and causes interference, the network doesn't panic. It just instantly and automatically finds a new path for the data. The second is self-configuring. You want to add a new device? It's simple. It just automatically finds its neighbors and joins the team. No network engineering degree required.
Okay, so that's the theory. But what does this actually look like in the real world? Let's check out a story from a family at Tiny Shiny Home. They took this exact idea and applied it to their 7-acre off-grid homestead, and in the process, they solved a connectivity problem I think many of us know all too well.
Their big problem was getting reliable internet across multiple buildings. And get this, one of those buildings had 16-inch thick earth bag walls, and another one was made of aluminum. So their old setup, which used a bunch of traditional routers, was just a mess. It was super unreliable. They had to deal with two different Wi-Fi networks. It was just a constant source of frustration. So, to fix this for good, they set some really clear goals. They wanted the same fast speeds everywhere, both inside and out. They wanted one single seamless network, so their phones wouldn't constantly be disconnecting as they moved around the property. And maybe most importantly, since they're not IT pros, the whole thing had to be simple to set up, easy to manage, and expandable for any future projects.
So what does a really robust, multi-building, high-speed mesh network like this actually cost? Well, for their entire UniFi system, and that includes all the outdoor antennas, the cables, the switches to cover their whole property, the grand total came out to about $1,700.
And the result? Honestly, it's the best kind of success story you can have with technology. It became so stable and so reliable that it just faded into the background. They completely stopped thinking about it. The internet just worked. And that feeling, right there, that is the ultimate sign of successful tech. Now, the Homestead story was all about making the internet they had better. But what happens when you don't have internet to begin with? What if there's no infrastructure at all? This is where mesh technology gets even more powerful, and where cool projects like Meshtastic come in. Meshtastic is this totally fascinating community-driven project. It uses these cheap, low-power radios to create a long-range, off-grid communication network. So think of it like this. You're creating your own private, encrypted text messaging service that works absolutely anywhere, with or without cell towers or satellites, because the devices themselves are the network. And just how long range are we talking about here? Well, get this. The world record for a connection using this exact kind of technology is an incredible 331 kilometers. To put that in perspective, that's about the distance from Los Angeles to Las Vegas, and it was achieved with inexpensive, off-the-shelf hardware. That just shows you the insane power of this decentralized approach.
So we've seen mesh for our convenience at home and for off-grid hobbies, but now we're going to raise the stakes. Because that same idea, a decentralized, self-healing network, can become a literal lifeline during a disaster when everything else we rely on fails.
And this is a really stark reminder of why this stuff matters so much. During massive floods in Texas, cell towers got damaged. The dispatch centers were getting desperate calls for help, but they couldn't reliably communicate with the first responders who were out in the field. And that delay, in a life-or-death situation, really highlights just how vulnerable our centralized systems can be.
Now contrast that with a mesh solution. In remote wildfires where cell service is basically non-existent, firefighters can just deploy these portable mesh nodes. In an instant, they create their own reliable communication network on the fly, allowing all the teams to coordinate and stay safe in some of the most challenging environments you can possibly imagine.
And the flexibility of this is just amazing. During the COVID pandemic in the remote Philippines, medics used these same mobile mesh devices to solve a huge problem. One device connected to a single satellite phone, and that one connection was then shared across the entire mesh network, allowing all the field medics to coordinate with rural hospitals and manage the crisis way more effectively.
So it's pretty clear that mesh is incredibly versatile, but it's not a silver bullet for every single wireless problem out there. See, different applications have very different needs, and that means we need different types of mesh protocols. It's really all about picking the right tool for the job.
So let's just look at a few quick examples. You've got your Wi-Fi mesh, like the one on the Homestead, which is awesome for high-bandwidth internet over short to medium distances. Then there's something like Zigbee, which is a low-power protocol that's perfect for short-range home automation. Think smart lights and sensors. And then you have something big like Wi-Sun, which is designed for these very long-range, massive-scale networks that you see in smart cities.
And this brings us to a really critical trade-off: speed versus reliability. Okay, think about the lighting for a huge rock concert. You need almost zero latency, that's signal delay. Every single light has to fire at the exact same millisecond. For that, a traditional star network is actually better because it's faster and more predictable. But for building automation, like making sure the fire alarm signal gets through no matter what, you prioritize extreme reliability over everything else. You'll happily sacrifice a few milliseconds of speed for the absolute guarantee that the message arrives. And that's where mesh totally excels.
So where is all of this heading? Well, when you take that extreme reliability we just talked about, and you combine it with the massive range and scale of protocols like Wi-Sun, you start to get the foundation for our future smart cities.
This right here captures the vision perfectly. Just imagine a city where millions of devices, we're talking streetlights, traffic sensors, electric meters, public safety systems, are all constantly talking to each other. They form this one massive, self-healing network that manages the city's resources efficiently and reliably. And this isn't science fiction. Protocols like Wi-Sun are making this a reality right now.
Which leaves us with a pretty fascinating question to think about. As our society becomes more and more reliant on billions of connected devices, for everything from the totally trivial to the absolutely life-critical, will these robust, self-healing, and often invisible networks become the true, silent backbone that's holding our entire connected world together?